In the next section, in 9-2, we're going to talk about quadratic functions. Now, you talked about functions before. Function simply means that you're going to have one input and one output, okay? Every output has only one input, and each input has one and only one output, okay? That's what a function is. Let's make sure we state it. Each x has only one y. That's what a function is. Each x has only one y. Now, yesterday we talked about things like y equals x squared and y equals 2x minus 1. In all of these problems, the axis of symmetry was x equals 0, meaning that whenever you graphed them, you would have like a point somewhere on the x-axis where it would be reflected around, whether it was like the normal y equals x squared, or whether you moved it up or down, or whether you made it skinny or wide. They all had the axis of symmetry of x equals 0. Today we're going to be graphing things like this, 3x squared plus 4x minus 10, where there is an x term. Now what the x term is going to do is it's going to move it either to the left or to the right, as well as up and down. Let's go ahead and take a look at what changes. The graph will now translate, and that means it's going to shift. The graph is now going to shift or translate left or right and or up and down all together. Now, how are you going to know what the shift is? We're going to help you find the shift by finding the axis of symmetry. This is still going to help you find that mirror image that you saw yesterday. Still going to help you find that mirror image. Now, the formula for finding the axis of symmetry is going to be, and this is the formula for a new axis of symmetry, is x equals opposite b, okay, see that negative sign? That means opposite b over 2a. This is also the formula, this is going to help you find the x value of the vertex. Now remember, the vertex is either that minimum or that maximum point on a parabola. We're going to find x of that vertex just by finding the axis of symmetry. Let's go ahead and start practicing some on the next page. What we're going to do is, these are 3 different examples. We are going to prove what the axis of symmetry is. See how here, it's hard to see, I know. See how they say this is the axis of symmetry right here, x equals negative 1/2. Right here they're telling you it's x equals negative 1. Right here they're telling you it's x equals negative 3 over 2. I'm going to show you how you can use this formula to prove that that's the axis of symmetry, the line that the parabola folds around. Alright, now let's go to our equations and look at the top. You need to be able to identify a, b, and c. A is always the number in front of x squared, b is always the number in front of x, and if there was a back number here, like plus 1, plus 2, plus 5, minus 2, that would be c. So in this case, c would be a whopping 0, because there's nothing being added or subtracted. So let's find our axis of symmetry. Let's prove that it's negative 1/2. So you would write x equals, let's keep the formula, opposite b or negative b over 2a. And then we're going to do x equals, now b up here is a positive 2. So we're going to do negative 2 over 2 times a, which is 2. Let's reduce. That's x equals negative 2 over 4. You have to multiply first. When you reduce that, that's x equals negative 1/2. Can you see how they work together, how negative 1/2 becomes negative 1/2? In the next example, let's prove that it's negative 1. So you'll do x equals negative b over 2a. Now let's plug in x equals, here's the formula of the graph below. Negative b is opposite b, so negative 4 over 2 times, what's a? Remember, a is the number in front of x squared. So 2 times a is 2 times 2. That's equal negative 4 over 4, because 2 times 2 is 4. And that proves that x equals negative 1. See how they have this vertical line at x equals negative 1? That proves that our formula is correct. Let's go ahead and check one more time. Here's the graph. A this time is 2, B this time is positive 6. So when I do x equals negative b over 2a, I do x equals negative 6 over 2 times 2, because a is 2. That's x equals negative 6 over 4. Make sure you always reduce. That's x equals negative 3 over 2. And again, that shows how the axis of symmetry for all of these three graphs can be found using this equation. Now, how do we graph these things? You need more than just an axis of symmetry. The only thing the axis of symmetry is going to tell you is it's just going to tell you where the middle of the graph is. I'm going to teach you a little bit differently than the book does, so follow my steps. First of all, find the axis of symmetry. Now just make sure that you do x equals negative b over 2a. Okay, negative b over 2a is the axis of symmetry. Make then an xy chart. Step 3, put the x value from the axis of symmetry in the middle of your chart. This is your vertex. Number 4, plug in, and I put this in capitals because you might want more to make a better graph. Plug in at least 2 points above and below the vertex. Number 5, if you skip evenly, okay, if you skip evenly, your graph is going to be a perfect mirror image. And that's if you skip evenly. Let's take a look at problem 1 and try this. Let's follow the steps. Here's our equation, x squared minus 6x plus 4. Let's make sure you know what a is. A is the number in front of x squared. This time it's a 1. B is the number in front of x. This time it's minus 6. C is the number in the back. This time it's a plus 4. Let's go ahead and follow my steps. Step 1. Find the axis of symmetry. X equals negative b over 2a. Okay, so that's going to be what's opposite of our b? Well, our b was a negative 6. So this time we're going to do a positive 6 over 2 times 1 because a is 1. And that's going to reduce all the way to a 3. Step 2, make an XY chart. Step 2 is not bad. Step 3. Step 3 is kind of with step 2, so why don't we kind of, in this circle, why don't we put steps 2 and 3? Okay, this is steps 2 and 3 together. Steps 2 and 3, that's better. Alright, so it says to put your vertex in the middle. Now remember, this 3 is the x value of your vertex. I'm going to put a v beside it so you remember that that's vertex. Step 4, plug in. Okay, so step 4 is on your chart. Plug in some numbers smaller than 3, like 2 and 1. Plug in some numbers bigger than 3, like 4 and 5. Now we're going to have to plug all of these in. Are you ready? This is your equation, y equals x squared minus 6x plus 4. Let's plug in 1. So we're going to do 1 squared minus 6 times 1 plus 4. 1 squared is 1, minus 6 is negative 5, plus 4 is negative 1 at the end. Plug in 2. 2 squared minus 6 times 2 plus 4. 2 squared is 4. Minus 6 times 2 is 12. 4 minus 12 is negative 8. Plus 4 is negative 4. Plug in 3. 3 squared minus 6 times 3 plus 4. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is negative 9. Plus 4 is negative 5. Now these values down here, you can double check them by plugging them back in. But I know I did these ones up here right, so these ones are going to be mirror images. But plug them in if you're not sure. Go to your chart and let's plot our points. I like to plot the vertex first. It makes it a lot easier for me. This, remember, is your vertex. So if you need to make it a point, it's going to be the x value we had and the y value we got out. So 3, negative 5. That's right 3, down 5. There's your vertex. Notice that the vertical line here, it's hard to see, but you see that vertical line I kind of did dotted? That's your axis of symmetry of x equals 3. Let's keep plotting. 2, negative 4. 1, negative 1. 4, negative 4. 5, negative 1. Those are the points from the XY chart. Just take your pencil, make a nice U shape, and you have your perfect parabola. Notice this time it shifted to the right and it shifted down from the origin. Let's try it again in the Got It. We have a new equation. Let's follow our steps. Step 1 is the axis of symmetry. That's negative b over 2a. Okay, let's identify A. A is negative 1. B is positive 4. C is negative 2. And that came from my equation. So if I do opposite B, this time I'll do a negative 4 over 2 times A, so over 2 times negative 1. That's really negative 4 over negative 2, which is a positive 2 at the end. So I have my x value now for my axis of symmetry, if you want to write that down, if you want to study it. That's your axis of symmetry. Step 2 and step 3 is making your XY chart appropriately. Remember where your vertex goes, or the x value of your vertex. We're going to put it right here, positive 2. We're going to then, step 4, we're going to surround positive 2, go down to 1 and 0, go up to 3 and 4. Now let's plug all of our numbers in. Remember, you plug them into the top equation. Watch carefully as I plug in. You see this negative in front of your x squared? That is a very difficult point, I think, for many students. They don't know what to do with the outside negative. So watch. Let's do 0 first. 0 is going to be the easiest. Negative 0 quantity squared plus 4 0 minus 2. Notice how I'm putting the negative sign outside of the parentheses. X, whatever you have for x, goes inside. I don't care if the inside is negative or positive. Whatever x is goes inside your parentheses. The negative stays on the outside because this negative was in front of your x. Well, that's just 0 plus 0 minus 2 is negative 2. Let's do 1 now. Negative times the quantity 1 squared plus 4 times the quantity of 1 minus 2. 1 squared is 1, make it negative. Negative 1 plus 4 is 3, minus 2 is 1. Let's plug in 2 now. Negative quantity 2 squared plus 4 quantity 2 minus 2. 2 squared is 4, but we have to make it a negative. So negative 4 plus 8 is 4, minus 2 is 2. If we did these ones correctly, which we did, these will be perfect mirror reflections. If you're not sure why, plug them in and prove it. Let's graph our points. 0, negative 2 is over 0, down 2. 1, 1 is over 1, up 1. 2, 2 is right 2, up 2. There's my vertex. 3, 1 is right 1, up right 3, up 1. 4, negative 2 is right 4, down 2. Look at the perfect mirror image we have. Connect, you have an upside down parabola, and it's upside down because A is negative 1. And do you see your axis of symmetry? The axis of symmetry is where our parabola would fold. In lesson 9-1, you used the fact that h equals negative 16t squared plus c. You did that to find the height h above the ground of an object falling from an initial height of c at time t. Ooh. That just means that you would just, like, remember the acorn problem? You would just take the acorn, you drop it, and then a c would be how high you dropped it from, and negative 16 is the pull of gravity. If an object projected into the air, given an initial upward velocity v, continues with no additional force acting on it, the formula h equals negative 16t squared plus vt plus c gives its approximate height above the ground. So you guys see this plus vt? This is if you, like, threw something up. in the air. Okay? What that means is that it actually has a beginning velocity. So yesterday we were talking about objects yesterday would just be dropped. Today we're going to talk about the objects that are thrown or that had a type of initial velocity. I'm going to finish this problem and the next one in one more video.